Inverter.
Welcome to ClickMyProject.com. The title of the project is Estimating Electric Motor Temperatures with Deep Residual Machine Learning. And the abstract of the project is most traction drive applications lack accurate temperature monitoring capabilities, ensuring safe operation through expensive oversized motor designs. Classic thermal modeling requires expertise in model parameter choice, which is affected by motor geometry, cooling dynamics, and hotspot definitions. In this process, deep convolutional neural network with residual connections are empirically evaluated for their feasibility on predicting latency, high dynamic temperatures continuously inside permanent magnet synchronous motors. It has been found that the mean squared error and maximum absolute deviation performances of convolutional neural network with residual connections meet those of classic thermodynamics-based approaches without requiring domain expertise, not specific drivetrain specification for their topological design. Finally, learning curves for varying training set sizes and interpretations of model estimates through expected gradients are presented. The flow diagram of the project is first we need to start our program and select the permanent magnet synchronous motor dataset and view the sample dataset in working console directory. Then it applied into data pre-processing method. In data pre-processing method we need to clean our data like we need to check the missing values in our dataset. If it is any missing values in our dataset, we need to replace the missing values into the unique value of 0. Then it will apply into model selection. In model selection we need to choose the independent variable and dependent variable, and in dependent variable we need to consider our target value like our main features, and then we have to split our dataset into training dataset and testing dataset. Then we have to directly apply the inputs into convolutional neural network regression algorithm. In that we have to find the prediction of mean square error value. I have run my project in Google Collaboratory, and this is the sample dataset of PMSM. Like it's a electric motor temperature dataset, and I have checked the information about the electrical motor temperature. These are the columns are contain our dataset, and these are the data types of our dataset. And this is the described value of our dataset. In that we have to find the count value, mean value, standard value, minimum value, and 25 to maximum percentage of value of every columns in our dataset. And this is the count plot of the dataset. And in that I have checked the missing, if it is missing values in our dataset. If it is any missing values in our dataset, we need to replace the missing values into unique value of 0. And this is the heat map of our dataset. And this is the convolutional neural network summary result. These are all the inputs and output results of the every layers. And in that I have train our dataset and find the result based on the mean square error value, and the final mean square error value is 0.0121, and the validation mean square error is, and this is the training mean square error and validation mean square error plot. And these are all the motor speed and testing speed, auto speed, and stator yoke and starter winding and stator tooth visualizations of our process.